Okay, welcome everybody to this talk that I've called The Anatomy of Real-World Apps. So, for those of you who wonder who I am, my name is Marius. I used to be a Qt developer. I started in Trolltech in summer 2002. And was part of the team that developed the item views, the main developer behind the item views framework. And I was the team lead for the Qt widgets team. And then, a little over a year ago, I started my own company together with a colleague, Espen Riskedal. So now we're doing Qt applications, basically building on the work of all the ingenious Qt developers that have been working on Qt for our benefit, of course. So part of the point of my presentation today is actually also a bit of the change of perspective, because now I've actually seen two sides of the fence, both the perspective as the Qt developer on the inside, and now as a commercial Qt user, as in I make my daily living of writing Qt applications. So Qt has now actually managed to produce a few apps. These are some of the apps that we either have in Nokia Store or elsewhere, or are in the process of publishing. And as you can see, we actually are very cross-platform in the sense that we take our applications and we deploy them to as many platforms as we can. And these are some of the platforms for some of our apps. Some platforms we just do as experiments, others we deploy to the store, so you can buy them. And I want to point out, actually, for this Fly app that we have, this airplane icon, we actually now have in the Android market, and it's a Qt app. And my colleague is actually doing a presentation about targeting Android with Qt applications in parallel, and he will be doing the same presentation, I think, on Wednesday. So since you're here and watching my presentation, you should definitely go and see his presentation on Wednesday. By the way, I'm very thankful for you guys showing up. It's awesome that you actually managed to fill up the whole room. One little thing before I forget. I like to have sort of a continuous communication between me and you, so feel free to ask questions at any time during my presentation. There is one thing, though, that we have to remember, and that is that since this presentation is being recorded, you do have to use a microphone. So please wait for the microphone to come to you before you start asking your question. So I would just say that raise your hand whenever you have a question, and somebody will bring you the microphone. Before I start the actual presentation, I want to tell you a little bit of a story. So when Espen and I started the company, we talked about what kind of applications we wanted to make. And in Scandinavia, we have this music streaming service that's similar to another music streaming service you may know, which is called Spotify. So this streaming service in Scandinavia is called WIMP. And yeah, we were not part of choosing the name. So I don't take any blame for that. Anyway, half year after we had started the company, we actually managed to get the contract for creating the Symbian client for this music streaming service. And up until that point, we had created a few apps that were purely QWidget based, basically because before January this year, there weren't any phones with Qt Quick deployed on them. So this application was our first real Qt Quick application. And it was a project that spanned over several months, and it's a fairly sizable app as far as mobile phone apps goes, and fairly advanced. And we learned a lot during that process about writing bigger applications and writing Qt Quick applications. And this particular image or picture that I'm showing you was actually one day when I was walking to work, I think, and I passed a bus station, and bus stations usually have these posters. And in this case, they had an advertising for the new Nokia C7 with a screenshot. Excuse me. And as you can see, it's from WIMP. So, and that's sort of one of those moments where you're happy to be a developer, because suddenly your application that you've been working really hard on and putting a lot of effort and feelings into is suddenly shown to the world on a big poster all over, I think, Norway. So that was a sort of a little moment where you sort of get payback from, or get sort of a little bit of how do I put it, something back for doing software development. It's the kind of thing that sort of motivates at least me to do software. Anyway, I'm not going to talk too much about WIMP itself in this presentation. I'm going to talk about the lessons we learned during this project and show you how we applied it to another application that we're actually in the process of finishing right now. We're supposed to be delivering this project end of this month. So what you're seeing is actually an application that's in, I would say, it's probably still unfinished, so there will be rust spots. But still, you will see a real application that's going to be deployed to the Nokia Store and will be available for download. And I will show you code and also talk a little bit about the approach to design and the internal structure of the app. So really, what I'm going to show you guys is sort of a bit of our secret sauce in Qtax for doing applications. And I hope that will help you guys when you do your own applications and maybe give you some ideas of how to do things better. So I'm not necessarily claiming that we have the one true way of doing things, but I'm hoping that by sharing our experiences and our ideas, it will help you guys, and maybe you guys will be inspired to share your ideas and your approaches to do applications so we all can benefit from sharing this knowledge. So I'll give you a little bit of a moment to ponder this question. So the thing is that we all strive to write clean, beautiful code and clean, beautiful structures. We start with a solid foundation for our applications, but at some point, almost inevitably it seems, we seem to either run out of time or something, and we start making shortcuts. It's an unfortunate truth, but it means that when we start making the application, we need to have a very solid structure so the application code can actually handle when we start making those shortcuts and making changes and maybe making changes in a way that's not necessarily the best and the cleanest way. But since in our case we're working for a customer and we're basically on the customer's money and time, sometimes the priority is to get the product finished rather than having beautiful code. It's not the ideal case, but that's the harsh reality for commercial software developers, unfortunately. So, the idea is to find a way, an approach that gives you a solid foundation for your application. And I want to talk a little bit about how we look at our application just from a very high level. So typically for us, actually I think almost every one of our mobile phone applications have been basically an interface towards some sort of online service. It basically just displays data that's being fetched over the net from some sort of service. And I think that's the case for the big majority of mobile phone applications. So the way we look at our application is basically divided into two major parts. You have the user interface layer and the backend. And in the backend, we typically do some sort of networking or remote procedure calls or something like that. We do some sort of parsing or processing of the data we get back. And we do some sort of massaging to either, in our case for the music service, play back the data or display it in a sensible way in the user interface. And in our case, we use QML for the user interface layer, and we use Qt and C++ for the backend. And I guess that's not completely uncommon. I guess that there are more people doing that here. So this is, of course, only partly true. We also use other things in the backend. We use Thrift, for example, in some cases for communicating with servers and other libraries. But in large part, we use Qt and C++. Now, to bridge between the UI layer and our backend, you typically, in QML, you would use a QObject with signals, slots, and properties, right? Another thing that you typically use is item models. So we use actually item models based on the abstract item model extensively. And this is actually one of the first lessons I'm going to talk about that we learned when doing WIMP. Because QML allows you also to serve lists of QObjects. And in many cases, that's very, very convenient. The problem is that it's not very flexible, because you cannot change the list without actually QML getting into trouble and not being able to update it correctly. And don't talk about moving elements within that list. So I actually started out implementing our lists in WIMP that you see when you're scrolling through tracks and whatnot as lists of QObjects. And that worked for a while until I needed to reload the list and basically change it to something else. And then it all fell apart. So I had to go back to implementing item models. And the lesson from that is that you might as well implement your list as an item model in the first place, because there's a very good chance that you will have to end up doing that anyway at some point. And then, another question. And this is actually probably the key point of my presentation. You get it right here. because I want to talk about actually not just one hero, but actually two heroes. There are two developers in Oslo that works for Qt that are actually sort of the quiet type of developer. They're not bragging about themselves or their work. They're both extremely good developers, but they're not very visible. And they have done a framework that has saved me countless of sleepless nights, and I would attribute the little hair I have left on my head to them. I would have much less if they hadn't done their job, because they created the Q state machine in Qt. And it's a framework that's not getting too much attention. It's not very glamorous. And now, talking about going to Qt 5 and all these things, it's almost like it's being overlooked a little bit. But this is a fantastic framework that is, in our case, the center of our applications. And we actually expose it to QML and use it extensively there. And then some of you might ask, so QML has states, why are you not using QML states? Anybody in this audience that are actually using QML and QML states extensively? Yeah. Then you might have run into an issue with QML states. The problem is actually almost a naming issue. Because when I think of a state machine and states, I think of the concept of state charts. So if you guys are software engineers, you probably heard about state charts when you were in university or college. It's a very well-known computer science concept. QML states are not really states in the state charts kind of way. It's not a bad thing in QML. It's very, very handy to have, but it's a bit of an iffy naming issue. I would call it something like property value setters or something similar, because that's basically what they do. They have a collection of property values that they set on specific objects when you activate them. So when I'm now talking about states and state machine, keep in mind the separation between QML states and Q state machine states. They're different concepts. They do different things. One of the big issues that I ran into with states in QML when we were doing the WIMP application was I started out actually thinking that, hey, I will build a huge state hierarchy for WIMP with QML states. But there's no guarantee, no safety with QML states for when you transition, when you move from one state to the other. There's no inherent restriction on moving from state B to state C, for example. You can move from any state to any other state at any point. It's not a big issue when you have small applications. But once you get to a more complex code base and more complex structure, this doesn't scale very well. And this is where the Q state machine framework actually comes in, because there it's very well defined when you move from a state to another state, what conditions are involved, and you will only move from one state to another state when, first, you're in this case, say you're moving from state A to state B when the next signal is emitted. You will only move to state B when you're in state A and the next signal is fired. If you happen to be in state C at that point, you will not be able to move to state A because there's no definition saying you can move there. You will only be able to move to state B, but you will only be able to move to state A because that's where you have defined a what we call a transition from state C to state A. So basically, you have these very strict rules for when you can move from one state to the other and what condition needs to be fulfilled for that to happen. And that gives you a lot of security for what state your application is in and when it moves from one state to the other. You can be certain that the internal state of your application is sane. So here's sort of the summary of our approach here that I'm trying to get across. This is the core principle that we're using when we're building applications. So it's skeleton, muscle, and skin. I will explain. For now, you can ponder this little drawing. So what I'm presenting is, of course, not necessarily the finished product. It's a concept, it's an idea, it's an approach. Of course, it has its roots in our experiences, but it can, of course, be refined. And we have, of course, taken this approach and refined it when we now apply it to this application, which I'm going to show you a little bit of now. This application is actually, it's another music streaming service, but it's different. It's a service that's being run by the Norwegian National Broadcasting Company. It's called Urørt in Norwegian, which means untouched. What it does is that it allows unsigned bands to upload their music and their profile to a web service to get exposure and then let people play their songs and rate them and like them and favorite them and post them to Facebook and other places. So it's a service to give visibility to unsigned bands, basically. So now let's see if it works. So here we have it, the main screen. It starts out with a splash screen that's already been displayed. And here you can see that we have different views. So the way we've organized this is that we have a hierarchy that is just our mental model of this user interface. So we have the concept of screens. In this case, we see what we call the view screen. And that's because we define these as views that you can access through a toolbar. And you can see that some views have tabs. So we have these three levels. We have screens, we have views, and we have tabs. And you can, of course, go to a screen to play a track, for example. Yeah, you don't hear much because this little phone doesn't have much of a speaker. But here's the application. And now we can switch back, I think. So what I'm going to tell you now, or show you now, is the flow, the approach we had when we were starting out developing this application. So the first thing we do is actually we sit down and sketch out the UI structure. In other projects, you would probably get this handed from a UI designer, for example, or somebody that's just sketching out the concept on a napkin or something like that. And then you turn this into a hierarchy of states. So you sort of think through the various screens and other UI levels that you want, and you turn this into a hierarchy of states. For each level, you have transitions between the states, how you can move from one state to the other. So in this case, you can see the top-level states, and you can see that we start out with the splash screen, and we move to what we call the view screen. And from there, you can move to various other screens. And in the view screen state, you have sub-states. In this case, you have 4 states representing the 4 views, or if you can imagine, the 4 buttons on the toolbar. And of course, since it's a toolbar, you can navigate from any state to any other state on this level. And if we drill even further down, you see that if we choose one of the view states, it had a tab bar with 3 tabs, which represents 3 lists that you can see. And these are represented as 3 substates again. So the approach I take is that basically I go through the sketched UIs, the concepts. I might draw it up as a state chart, I might not. But in the end, I start out building the state machine that's going to represent the core of the UI in the application, and also how you move from one part of the UI to another part of the UI, and which rules apply. So how you are allowed to move from one screen to the other, for example. And this, in this particular app, took me about, say, half a day to a day to build this up. And what we do, you don't necessarily have to read all this, but I wanted to show you, these are the 14 states that we end up with in the Urart app. And the way we expose it is we expose every single of these states as properties of the state machine object. And the state machine object will be exposed to QML. We'll get more into that in a little bit. And to be able to move from one state to the other, we have to define transitions. And then we're talking about transitions in the state chart sense of transitions, not animations, but the condition from moving from one state to the other. And I typically use signals, mostly because I'm lazy, but you can also use events, and you can specify other things. But typically, the state machine will have a set of signals that I will call that will trigger a transition if the conditions are there. Meaning, if you're in the right state, then the signal will trigger a transition from that state to another state that I've defined. Another very handy feature with the QState machine is the history state. This is a lifesaver. I hear some people agree. The thing is that, say you're in the view that had the 3 tabs, and you click on one of the tracks. That will take you to the player screen, which is a different state on a different level. You would, however, expect that when you navigate back to the view with all the track lists, that the same tab is active. You do that by having a history state that will remember the state of the internal state, the substates of the view screen. So the thing is also that you can, of course, achieve this by not having a state machine remembering this, but you just remember it by looking at which tab is pressed or active. The problem then is that you distribute the knowledge of the state of your UI to all these different UI components all over your QML files. And if you were to, say, change your UI and remove the tabs and use some sort of other concept for this, the place where you save this state is gone. And you will have to re-implement it or do something else. Here, you'll have one place, one part of your code where you have your whole UI state saved, and you're able to inspect it. You can look through the states, and you can see which states are active, where is your application. And if you change the UI, even if you change to something completely different, say that you want to change from QML to QWidgets or to HTML, you still have the core structure of your application in the state machine. So we're almost there. We have a state machine that works, that has the conditions set up. We need one key feature to make this work with our UI. So we want to be able to connect our states to QML, and we do that through a property that I've called isActive, which basically says whether or not a state is active or not. And the way I use it is this way. And if we remember this skeleton, muscle, skin sentence, this is where the skeleton and the muscles meet. This is where they connect. So here you see that I used the isActive property of a state, in this case the splash screen state, to activate a QML state. Basically making the QML state set the property values on the specified objects. And just to make the whole circle complete, here's how I would activate a state from QML in the state machine. And this means that it will drive the whole mechanism from changing the state in the state machine, activating the state. Yes, there's a question. Yes? Yep.
My question is, you have different views in QML, and are they always loaded? I mean, this implies like you only to put the other screens on site.
In our case, yes, they're always loaded. In WIMP, we use loaders. So that's just, I view those more as an optimization feature than sort of fundamental, how do I put it, piece of the UI structure. So, but this, you can of course use this with loaders too.
And would you recommend to use loaders or?
Yes, well, I mean, it's this old saying of, premature optimization is the root of all evil, right? So I would say that loaders are excellent for saving memory. However, they do take up time. They're slow. So you want to use them strategically. I've done, actually, I mean, even now with WIMP again, I've overstepped the line and used loaders too much and seen that the startup time was horrendous because all these loaders were triggered and the UI started to basically behave sluggishly, and because it was always accessing the file system. So you have to be you have to see where it makes sense to use loaders and where it makes sense to keep things in memory and just move them out of the view. That's, wait for the microphone, please.
I was wondering about loaders. Do you actually have states that are loaded later? I think it's possible in QML, although it's not really a proper thing to do with state machines. I wonder if it works, or what is your approach here?
I don't know if we do, actually. I don't think so. I don't know of any inherent problems with loading states. I think that would be just like loading any other QML structure. But I cannot say that it's without any problems.
I was thinking the signal triggers, and then the loading starts, but the when condition misses the signal trigger because it wasn't loaded.
I think that unless it's loaded, there is no object in the QML object structure that would be able to receive the signal, basically.
Yeah.
This is just me speculating. I don't know for sure. I haven't read that code, but that would seem like the logical case for me. So I would guess, and this is guessing, I would guess that unless you have loaded the state, nothing will happen when you change the property here.
Okay.
There's a question in the back.
There's a number of Boolean properties, each one for each state. Is it feasible to use an enumeration instead?
Yes, that would be definitely possible to do. I think that my approach was basically out of pure convenience and maybe a portion of laziness. So, but I also think that just from an aesthetic point of view, it looks nice to be able to just say that this QML state is active when this internal state machine state is active. So it basically means that the code becomes very, very readable.
Okay, I was thinking about with having multiple booleans, you not exclude the options to have two of them being true. If you have an enumeration, the enumeration can be exactly one value.
That is true. However, since I'm building this on top of the Qstate machine, I am fairly certain that there's only one state that's going to be active at any point in time. Yes, another question. Can you wait for the microphone? If you raise your hand, she will see where you are.
There is a class named Qsc Xml, which is able to load an Qsc Xml state model.
Yes.
Have you ever tried to use this class?
No, I haven't, but it's a very, very tempting option. I have definitely looked at it and thought that that would be something I should look into, because it gives you the option of actually visually designing your state chart using visual tools, which might even make the initial development of the state machine even more rapid than just typing code. So yes, that's a very good tip.
What was the name of it?
Qsc Xml.
Yes.
Yes, there is a standard Qsc Xml, and there is a class. It's not distributed with the basic parts of Qt, but it's available at Nokia, and it can load an Qsc Xml model, and there is even a code generator, but I didn't try out the code generator. We are using Qsc Xml models, which are XML files, and they are loaded at runtime. And for our application, it's fast enough, and it's very, very comfortable to design such a state machine with a visual editor, and then just load it into your code.
Yes, I agree. Shall we move on? All right. So now we actually have some light in the end of the tunnel here, because now we have actually a very, very solid structure that we can start building our application on top of. So just to summarize a bit, the approach, the core message that I want to give to you guys today, that I want you to remember, is the skeleton where we build up the state machine. We connect the state machine to QML through QML states. That's where the muscle comes in. And this is actually an actual screenshot of the app that I showed you one day after I started coding it. And basically what I did was put QML rectangles as UI element placeholders, basically, on top of this state machine structure, and started adding QML states and transitions and layouts to sort of flesh out the UI on top of the state machine skeleton. So this is where the muscle comes in. And finally, we have a third stage, which is the skin, which is basically going through this UI sketch, sort of, that I did on top of the state machine, and changing out these rectangles with pix maps to make it look nice. And that's essentially it. There you have what I think is a very structured, quick, rapid approach to developing a very solid UI sort of solid UI with a very stable framework underneath. And the reason why I think it's stable is because I've run into problems where I had to introduce a new state because I think I had missed a screen, or I had misinterpreted how it was going to be navigated to. And I was pleasantly surprised of how easy it was to just change how I navigated to that state, or where that state was in the state hierarchy, and without any problems changing the navigation in our application without having problems with the UI or the structure or unknown states. You also have the benefit, of course, that you can change out the UI components without actually affecting the internal structure of your application. Okay, so now what? I have a few more points that are basically lessons learned by making all these apps that we have for different devices. Now see, Nokia ships a whole bunch of different devices. They've been very good, I have to say. I have been cheering about Nokia Symbian devices for a while because they did stick to what they call the NHD resolution, the 360 by 640 resolution. That made it incredibly easy for us to target Symbian 3 devices because they all had essentially the same resolution and form factor. The N9, we're happy about the N9. And the reason why we're happy about the N9 is basically because it has higher resolution, but it's the same aspect ratio as the old NHD resolution. So it's fairly easy to scale to. I have to say that personally, although the E6 is a brilliant phone, it did create some problems for us. And I'm going to show that to you in a couple of slides. It's actually quite hilarious. Anyway, just to sum up, these are the different pixel resolutions on the 3 devices that I showed you. So you have the N8 and I think C7 and E7, and I think good old N97 and N97 Mini already had this, the 360 by 640 pixels. Then you have the E6, with the 640 by 480, which, when you compare on the pixel level, is not too bad. I mean, they did roughly the same size, you can say. And then the N9 with higher resolution, but still not too different. There's the problem, though, that even though the pixel values or the pixel sizes are not necessarily that different, size-wise, the physical size of the screen is very different, especially if you look at the E6 versus both the N9 and the N8. And that leads to some rather funny issues. So here's a screenshot of WIMP on the E6. That looks okay. I mean, it's in landscape mode and all, but the sort of UI components look okay. Now I'm going to introduce the finger of my esteemed colleague trying to interact with this application. Kind of makes you feel like this, right? So these are kind of the things that you have to deal with when you're making, and this is more sort of a cross-platform app development thing. I know there are going to be more talks about this, so I'm sure I'm not the only one touching on this subject. But when you're developing applications, and we're developing applications and trying to keep the UI scalable and sort of flexible for these kind of things, but sometimes, like with the E6, you might want to actually fall back to redesigning the UI. Simple scaling, in this case, just wouldn't cut it. So I can show you some actual code that we are using, and this is from the Other app again. We have, in this case, just decided to ignore the E6 and say that, okay, well, fine, it will look strange and be difficult to use. But to sort of accommodate for at least the NHD devices, most of the Symbian 3 devices and the MeeGo devices, we do this. And I'm not saying that this is the sort of be-all, end-all of this, but this is our approach for now. And this is basically, we're exposing a context property to QML, and in QML, we have an object where we have properties for various things. And the thing is that we have a very strict rule. In every other object in our QML file, we are not allowed to have hard-coded values. If you're using values, margins, positions, font sizes, whatever, you will have to use values specified in what we call the theme object. So this Qt object here with the properties, we call a theme object. That means that all these variable values that we use to define the layout and the size of the UI, they're defined in one place, in the theme object. And we're not only using that for geometry and font sizes, we're also using that for pix maps. That has, of course, to do with different resolutions, but it's also to do with the fact that in many cases we're asked to skin the application using different pix maps. With WIMP, for example, the company that is basically running the service, they are also selling the whole system as a white label system for music streaming to other companies. And these other companies obviously want the apps to go with the service, but they want it to be basically have a different branding, different look. So we have to be able to change the look of the application by changing the pix maps. And we do that basically by changing the pix maps in the theme object, or even just changing the theme object to use the appropriate theme object for that vendor. So this is how we would use it. We have an image that's basically a property, and instead of setting the path directly, we have the theme object stored. So, yes, another question.
How do you access this theme object from other QML files? What we do in our app is we have this JS file, and we have some variables there. And we access those variables, we import the JS file. But I'm wondering, is there like a difference? Is this a better way to do it, or?
I wouldn't say that it's a better way to do it. But what we do is basically we instantiate the theme object in the main QML file. So it's basically available in the global namespace. Mm-hmm. Okay. So that was one point. I have another very short point about cross-platform code. Also a lesson that we learned when we were, in the beginning, basically what we did was we made Qt applications for Symbian. And now, lately, we've been asked by our customers to port them to MeeGo. And in the beginning, we thought, yes, that will be a breeze. It's just recompile and deploy. Turned out that that was not necessarily the case. And the reason is because the people making Migo Harmattan, for very good reasons, have made some choices that does make our life a little bit more difficult. So, you know, although Square is nice, it's not always the most, how do I put it, convenient for us in our case. So, this is just a one-slide thing. The problem that we ran into was basically that what I think is the window manager on Symbian devices handles rotation for you, meaning that when you go from portrait to landscape and back, it's the window manager that takes care of the rotation of your user interface. This is not the case on Migo devices. There you have to actually handle it in your UI code yourself. So they have given you some help by providing what they call the page stack window with the page objects that will take care of this rotation for you. The problem with that is, of course, that you need to have this as the top level of your UI code. So what we have ended up with is basically introducing ifdefs that load different UI files, QML files, based on if you're on Migo Harmattan or not. So basically, you can see that what we have here, if you look at the top piece of code, we have what we call the main window, which is what we normally would load, which contains all the UI code. On Migo, we embed that into a page in a page stack window. So you can see in the bottom piece of code how we basically load the different files based on the platform. So that's our way of working around the problem. It's okay, it's a little bit ugly. I don't like ifdefs if I can avoid them, but in this case, we couldn't. There's a question?
Concerning the ifdefs, actually I made the experience that you could avoid them if you're using different resource files for your different platforms. So you basically put the ifdefs out into the project file of Qt.
Yeah, you could do that.
That.
I think in this case we're not actually keeping the QML files in resource files, but loading them from the deployment directory. So it's sort of the new way of doing QML apps, as far as I know, where you don't really keep them in a resource file. But yes, you could definitely have different resource files for the different platforms. That's not a way of avoiding the code. So not saying that our solution is the best one or the only one, but it's a solution that we've found.
This is more of a general question. I was wondering how you organize your QML files. So they're basically UI files. Do you also have functions in there, JavaScript functions? Do you have code in the events, or do you forward to a function, things like that, properties?
Right.
You know?
I try to avoid having too much JavaScript code in general. I guess it's partly personal preference. Personally, I don't feel like JavaScript scales very nicely, so I try to keep it to a minimum. As far as I can remember, we don't have any separate standalone JavaScript files. It's always functions defined in the inline in the QML file. When it comes to events or signal handlers, I think that we, in almost all the cases, we write the code, the JavaScript code, if we need any inline in the signal handler.
Okay, so it's inline. You don't forward to a function.
No, no, I can't think of any cases where we actually do that. And in general, we try to keep the JavaScript code in those signal handlers to a minimum, meaning maximum of 10 lines. I mean, then we're starting to have big signal handlers.
Okay, thanks.
So that's actually all I have for you guys. I hope if I didn't solve all your problems, at least I hope I gave you some tips and some insights into how one possible way of approaching this kind of development. And I hope that this inspires you to find other approaches or refine this approach. And hopefully next year you can do a presentation on how you massively improved on our approach. Because I think that it would be awesome if we could actually use the developer days where we all Qt developers come together, where we can use this to actually also exchange ideas and approaches on a little bit higher level than just using the Qt API, but also how we approach software development. And this year I'm trying to give you guys some insight in how we're approaching it. Next year I would like to see some of you guys showing us how you approach your development problems. So I saw there was a question in the back there.
I've seen that you didn't show us how you solved the different form factor issue for different devices. Because I'm asking because because I've had a similar problem with a small device which had a vertical orientation and a larger device which had a horizontal orientation. And then, of course, the screen was bigger, 4 times bigger. And the designer said, okay, I'm going to use this extra space for stuffing functionality in that extra space. So basically what happened is that we ended up with lots and lots of code, which is, well, different. So we ended up with 2 different UIs mainly. Yeah. So I was just wondering what was your experience with that and how you solved that problem.
Yeah. Our solution to that problem was very, very simple. We ignored it. I'm not. Basically, we decided that this device came at the point where we were already done with the application, and the customer for our application were not. Basically, they were not insisting on us tweaking the UI for this particular device. So for us, it was an easy decision to say that, fine, then we will not spend time and effort trying to shoehorn the UI into this. I think that if I was asked to actually do the user interface for this, I would probably go with having separate QML files for at least large parts of the user interface. I don't think that trying to scale the existing user interface would work. I think you would need a basic new layout to make this work.
Thank you.
Yeah, there are more questions. I'm just going to do a little bit of indoctrination while we're answering questions.
Yeah, I have a question about how do you share your data from the models to QML? Do you use properties or?
Yes, we do basically 2 things. We use QObjects and properties, and we use abstract item models. So for single values, we use objects and properties, and for lists, we use abstract item model.
Just a quick question. Which kind of localization model do you use? Do you use the linguist and the rest of the things that Qt provides?
Yes, we use the whole Qt translation framework with linguists and loading translations.
Have you ever thought about moving the entire state machine to be instantiated in Qml?
For that to be possible, I would actually need something that at least approaches state charts, meaning I would need so-called transitions, the conditions for moving from a state to another state. And that's not really available in QML yet. I think I've heard that they're at least thinking about introducing something similar, but it's not there yet, so right now that's not really an option. All right, if there are no more questions, then I will say thank you guys for listening to me and my talk. And I will be around the whole conference, so feel free to talk to me and ask questions or tell me, you know, what you think about the approach or what you think in general, for that matter. And then I hope to see you around. Thank you.